So, the area between two curves. Basically, so far when we've been doing area, we were doing the area beneath the curve, and that was between the curve and the x-axis, right? That's when you were doing the definite integral. You were doing it between the curve and the x-axis. Well, now you're going to be able to find the area between two curves. So now you're not going to have just one curve.
Excuse me, teachers, at this time, would you please?
So now you're basically going to be dealing with two curves, and you're going to find the area between those two curves. So this integral right here from a to b of y1 minus y2 dx basically represent your two different curves, okay? Whatever those two functions are. In order to figure out the area between the two, you're going to probably have to do a quick sketch of them, because in order to determine which function goes first and which function comes second, you have to see which curve is on the top and which curve is on the bottom, okay? Because the curve on the top, you'll plug in for y1, curve on the bottom, you plug in for y2, and then you'll subtract it. No. So like basically you'll have two curves that they might love the x-axis, but basically you'll have, let's say you have like a quadratic and a line, and it asks you to find the area from whatever this point was to this point. But the fact is that the line is the curve that's on top, and the quadratic is the curve that's on the bottom. So whatever the line function was, we go for y1, and whatever the quadratic function is, we go for y2, and then you subtract it. That's how you go about figuring out the area between two curves. Does that make sense? We're going to do plenty of examples, so if that makes sense, I hope it makes sense. Okay. A and B still represent basically where the two curves intersect, okay, those points. So here we go. It says to graph the region bounded by the curves, quadratic and line, y equals x squared minus 2 and y equals negative x. We're going to write down an expression that gives the area of the region, and then we're going to find the area. We're solving this problem without a calculator, okay? So, y equals x squared minus 2. That is a what? A quadratic that opens up or down. Up, crosses the y-axis square. Negative 2. Now, where it crosses the y-axis, is that the vertex? How do we find the vertex of this particular quadratic? Yep. It is just the parent parabola shifted down to the parent parabola. This is that. Remember how you were afraid about remembering the old stuff? Here's a good review of quadratics. Remember, quadratic starts at 0, 0. You don't have to graph this one, okay? Quadratic, the vertex starts at 0, 0, and then what? Out 1, up 1. Up 3, out 1. And it was symmetric about the y-axis, right? So this right here is your parent function. So since my parent function just got shifted down to, all you got to do is literally just take these points and move them down 2 units. So your vertex is no longer 0, 0, it's now at 0, negative 2. This point goes down 2 units. So does this one. And then this point goes down 2 units. So those, I'll erase the ones we don't need. So this is actually the quadratic that we want to graph, okay? So there's y equals x squared minus 2. Now y equals negative x is what kind of a function? Say again. A linear function, which means it's what's the general form of a linear function? Y equals mx plus b, where m is the what? Slope. What's the slope of this line? And b represents the y-intercept. Where does this line cross the y-axis? At 0. So it crosses at 0, and the slope is negative 1, so that means I go down 1 over 1, down 1 over 1. Or up 1, left 1. And when you connect those points to form the line, you'll see that the line and the quadratic intersect each other. Okay? And you're finding the area of the region between those two curves. So you can see the area that we're going to try to find is right in here. Questions so far? That's a little review of graphing quadratic and linear function. Now we have to write down an expression that gives us the area. Well, the expression is the integral. From what to what? A and B are going to basically represent where the region is bounded between -2 to 1. Because that's where those two lines intersect, and that's where the shaded region starts and ends. And then we have to do y2 minus y1 minus y2. What's the curve that's going to be, what's the curve on the top? Y equals -x. So that means -x goes in for my y1 because that's the curve that's on the top. And then I subtract it from the curve that's on the bottom, which is x squared minus 2. Now you want to be careful because I'm subtracting that entire function. So that's why I put it in parentheses. Because you got to remember to distribute that negative. We can simplify this and make it a little nicer, can't we? Okay? So this is going to be -2 to 1 of what? Negative. So then there you go. There is the expression to represent the area of your region. And now we have to find the area. How do we find the area? Take the antiderivative. What's the antiderivative of -x? -1/2 x squared minus x cubed over 3, or 1/3 x cubed, plus 2x. And I'm going to evaluate that from -2 to 1. Now when I evaluate, what number am I plugging in first? The 1, and then I subtract it when I plug in the 2. Okay, so you always plug in your upper bound and you subtract it from your lower bound, okay? So everybody take, so that's algebra from here, okay? Everybody take a second, work out that math when you plug in your bounds and subtract them, okay? Yeah, so the area underneath the curve is basically 4.5, about 4.5. So not over 2.
So your y1 is always your top.
It's always your top function, and then y2 is always your bottom. Look at the next one. It says write down the expression that gives the area of the region bounded by those two curves, and then find the area using your graphic display calculator, okay? So, I need to write down the expression, which means that I need to see where these two curves intersect. So I'm going to pull up my graphic calculator, and I'm going to graph these two functions. What was the first one? 2e. The -x divided by 2. And my second function is x squared minus 4x. So I type that into y1 and y2. My first function. Probably not. Okay, so there we go. We clearly see which curve is on the top, right? For me, it was my blue function, which was my first function. And then the bottom function is the quadratic. So if I want to write my expression, the exponential function is going to be first, and I'm going to subtract that from my quadratic function, because that was the one that was on the bottom. Everybody understand that? Now, how do I get my bounds? I have to find where they intersect, okay? So I have to find this point here and this point here. So how do I do that? second trace, 5. And you wanna make sure you're closer to the intersection point that you want, or else it might give you the other one. I mean, you still need both of them, but move closer to the one that you wanna find first, because this one is your lower bound. So enter, enter, enter. So is my x value my y value? The x, and then we wanna make sure we use 3 significant figures. So negative 0.584. And now I gotta find my other intersection point. So second trace, intersects. I gotta move closer to that intersection point so the calculator knows. Insert, insert, insert. Y'all got 4.06? So there it is. There is my expression for the area bounded by those two curves. Now to find my area, all I do,
Can you plug it in?
plug in my calculator, yep. Huh? You can't do it on the graph. You guys remember how the guy did it on the graph? Second trace, 7. My lower bound is I can type it in. Okay, negative 0.584. Yeah, when you do it this way, it's in relationship to the x-axis, not in between two curves. Okay? So you are gonna have to do it the other way. Um, and the thing was, it's bounded between the x-axis. Make sure you include parentheses so you're calculating those and subtracting the entire quadratic function.
Isn't it the other way? The quad, oh wait, no, the quadratic. Never mind. I wrote it wrong.
Be careful about that. Is that, are those the right functions? You guys got 14.7? Alright. So very similar to how you were doing it in relationship to the x-axis, okay? You still have to do your bounds, but this time it's not where it is on the x-axis. It's basically where the two curves intersect each other. Curve on the top minus the curve on the bottom. Take the antiderivative and you evaluate. Okay? I want you guys to do the next one on your own. And then we'll come back and we will compare answers. You guys can use your calculator for this